Okay, building off of what we talked about last week, which was learning how to evaluate square roots and cube roots, we are just building onto that and learning how to solve with them. Good news is not much is different. There's just one kind of maybe new thing that I will explain to you, but besides that, the concept of square roots and cube roots are exactly the same as we learned last week. So again, just going to walk through these examples with you. I will leave the written ones that I'm going to be writing in this video on your assignment so that you can glance back at them instead of always having to rewatch the video. And so let's get started. There's 3 examples. All right, so the first one, we're going to solve equations involving perfect squares. So that, remember, that's whenever the 2 is in the exponent position. Darius is restoring a square tabletop. He wants to finish the outside edges with a piece of decorative molding. What total length of molding will Darius need? So again, it's always important to know what are we trying to answer here. We want to find out what is the total length that he's going to end up needing. And it already tells us a very important piece of information. The picture shows us that the area of that square is 25 feet squared. Remember, area is length times width. So we'll draw just a small little diagram. It's kind of already done for us, but just so you can see what we're talking about. So here we have our square. That's a terrible square, so sorry. Area equals 25 feet squared. I really should make that bigger. Here, let me do this. Let me start fresh with that. Sorry, my drawing skills are terrible. Let's try to make that a little bit bigger, but still a square. That'll be okay. So again, just drawing our own little diagram, 25 feet squared. And on a square, each side is represented with just the letter S. Again, you could do length times width, L and W, but on a square, we know that every single side is exactly the same. So what we're going to do is we're going to take the information we know about an area, and it's actually given to you right here. We know area is length times width, or in other words, side times side for a square. Well, remember, if you have 2 S's, you can squish them together and just make that S squared. That's where that's coming from, there where I highlighted. So we're going to take that formula, area equals S squared, and we're going to replace the letters with the information that we know. We already know the area, the letter A. It's 25 feet. So instead of the letter A, I'm just going to replace it with the number 25. And then bring everything else down. So our goal, just like usual, our goal is to get the variable by itself. So in other words, we want that letter S to be all by itself. And right now, we still have that little exponent of 2 stuck with it. So this is where our whole square root comes into play. Something that is being squared, meaning S to the second power, that's called squared. The opposite, the reverse of that, is to take the square root. So in order to get that S all by itself, to get that exponent to go away, we need to take the square root of both sides. Remember, what you do to one side, you have to do to the other side. So what's going to happen here, let me change my color, is the square root symbol and the square, the number 2, they cancel each other out so that you're left with just the letter S. That's why we did that. And remember, square root means it should be 2 numbers, 2 of the same number, I should say. So what times itself gives you 25? Well, the square root of 25 would be 5, because 5 times 5 gives you 25. Now, here's the thing I said at the beginning is probably going to be the biggest difference in this lesson. The answer is not just 5 right now. It's actually what we call a plus, so a positive 5 or a negative 5. So in other words, we actually have 2 answers here. And here's why. I'm going to draw it out. I'm pinching a little bit so I can move over. Again, this is probably going to be the newest part. It's not hard though at all. So here's the reason why we put that plus or minus out front. A positive 5, let's think in reverse. I'm going to draw an arrow so it comes back to this. If we plug that in, what is 5 squared? So what's 5 times 5? Hopefully you know it's 25. But what if it's a negative 5? So in other words, what's a negative 5 squared? So what's negative 5 times negative 5? You should know that two negatives make a positive, and so that also gives you a positive 25. So that's why we have the plus or minus out front of the number whenever you take the square root, when you're solving, only solving, not like last week. We didn't have to do this at all last week. But here's where we have to kind of wrap it back around to figure out the exact answer. We're trying to figure out the length of a piece of molding. Or we'll even just say, maybe if that's confusing, a piece of wood. We're trying to figure out the length of a piece of wood. Can you have negative length if you're building something? I hope you're saying the answer is no. So that means that in reality, so math-wise, you would have two answers, plus or minus 5. But when we're talking about this problem that we started with, the length of this piece of molding, negative's not even an option because we're building something. So here's our conclusion. So let me see if I can try to write it kind of neatly. I'm going to go up here where there's some blank space. So since length is positive, each side length of the tabletop is 5 feet. Okay, so let's again just piece that together. We knew it can't be the negative 5, the plus or minus, so that minus is now gone because it can't be negative length. So that means each side of the tabletop is 5 feet. But go back to where I highlighted, what is the question we're trying to answer? What is the total length? Total length. So in other words, if there are 4 sides and each side is 5 feet, how much does he actually need? We'll do green. So again, 4 sides, 5 feet each. So that means Darius needs a total of 20 feet of molding. So this is what we were truly trying to answer. So again, make sure you answer the correct question. Don't just stop at 5 feet. The question here was, what was the total length? So we need to make sure we're answering the entire question. Okay, so that's square, take solving whenever you have a perfect square. Okay, so again, just going to follow through with the try it problem, walk through it a little bit faster. So here we have another square. What is the side length? Is what all we're trying to figure out is the side length, so we don't have to do that extra step of total length or anything. So if the area is 100 meters squared, that's what we're going to start with. So 100 equals s squared. And again, in order to take the to get that power of 2, that exponent of 2 to go away, we have to take the square root of both sides. So I'm going to kind of write that little mini step in the middle. It's kind of what's happening between this block and the next empty block. So in other words, what number times itself gives you 100? That would be 10. Oh, actually, no, that's what they wanted us to do right here. Sorry. And then what's the square root? You take the square root, it would be plus or minus 10. Remember, plus or minus. But again, in this problem, we're talking about side length. So length cannot be negative. So each side of the square is going to measure 10 meters. Okay, moving on. Now this one is talking about perfect cubes. So Kyle has a large cube-shaped terrarium for his iguana. He wants to cover the opening with a square screen. What are the dimensions for the screen? All right, so let's start with this first. All right, so one piece of information, we know the volume of that entire cube. A terrarium gets hard to say. I'm just going to call it cage. Of that cage. But we also need to know what volume is. So volume is always length times width times height. But again, we're talking about a cube where every side length is the same because it's just a bunch of squares put together. Cube is all the same lengths on each side. So volume is the same as side times side times side. In other words, S cubed. And we're going to follow the same exact steps as we did for that last problem. So we know what the volume is. It's 343 feet cubed. So instead of V, I'm going to put that number there. And we're trying to figure out what is the length of each side. So again, same steps, just a different power. So last problem, it was squared. This problem, it's cubed. So we're still going to follow those same steps. We have to take what's called the cubed root. And again, that's going to cancel each other out and leave you with just the letter S. And now we need to figure out what number 3 times gives you 343. That would be 7. 7 times 7 times 7. Now here's the difference. If you noticed, when I gave you the answer, this time I didn't tell you to put the plus or minus. So we're going to do just a quick discussion and a note about that. So let me draw. I'm trying to draw without putting my hand on the iPad. The value of S is not plus or minus the cubed root of 343. So in other words, we're not using the plus or minus for this problem because if you would take a -7 and cube it, it's not going to give you back 343 just like the other problem. Negative times negative times negative means your answer would be negative. So let me see if I can kind of box that in for us. So that's why anytime you're doing a perfect cube, you don't have to worry about the plus or minus because the negative answer is never going to be a possible solution. So in other words, go back. If each side is 7 feet, then, and we want to figure out what are the dimensions for the screen. So this screen right here, which is a square, that means the dimensions of the screen are 7 feet by 7 feet. So this is what we were trying to answer. So again, you don't have to worry about the plus or minus situation because anytime you have something with a negative being multiplied 3 times, your answer will still be negative. Okay, so let's try the try it problem. So it says x cubed equals 64. Okay, I'm just going to rewrite it for us. So x cubed equals 64. And all you have to do, again, your goal is to get the x by itself. So in order to get rid of that power of 3, we're going to take the cubed root. So again, oh, gotta make sure you put the cubes there. Very important. So the cube root cancels and leaves you with just the x. And now we need to figure out what number times itself 3 times gives you 64. In this case, it's 4. So 4 times 4 times 4 would give you 64. And again, this was just a practice problem. There was no story or application to go along with it. So you don't have to worry about, 4 feet, 4 inches, anything like that. It's just done. Okay, and then lastly, let's focus on these ones. So far, everything we've done has been what's called perfect squares and perfect cubes, meaning that the answer you're going to get is going to be a whole number. It's going to be some type of integer, meaning it's not going to be like 4.135. It's not going to be some weird fraction. It's going to be a nice, perfect number. Well, this last example here, example 3, is what we call imperfect squares and cubes, meaning it doesn't end up being just a simple 4 or a simple 5 or anything like that, or a 10. It's going to have some kind of weird answer. So what we're going to do is the same exact steps. It's nothing trickier. Actually, you might even find it easier. So let me zoom in a little bit. Let's look at this first one. So we're still wanting to get x by itself. So x squared equals 50. Well, if we want to get rid of the squared, that means we need to take the square root. Again, that's going to cancel and leave you with just x. And then so we need to figure out, okay, what number times itself will give you 50? Well, the closest to it would be 7 times 7, which is 49. But there's nothing, 8 times 8 is 64. So there's nothing that multiplied by itself gives you 50. So in a case like this, and you can type this into your calculator as well, and you'll see it's probably going to be 7 point something. You will see that it does not give you a perfect number. So in a problem like this, you'll do more with this in high school, but for now, we're going to leave it just as we see it. And remember, when you're doing the square root, we have to use the plus or minus option. And we're just going to leave it that way. We're not going to worry about writing a bunch of decimals or estimating the number. We're just going to leave it exactly how it is. Now again, when you get to high school, you'll learn how to kind of break that apart. If we have time, we'll talk about it, but for now, we're just going to keep it simple and leave it just like it is. So let's try the next one. The cubed root. So x cubed equals 37. So again, we need to take the cubed root of both of those things. What you do to one side, you have to do to the other. That cancels, leaves you with just x. And I actually believe 37 is a prime number, meaning nothing besides 1 in itself is multiplies to give you that. But there's no number that's going to multiply, 3 times, I should say, to give you 37. As we saw earlier, 4 times 4 times 4 was 64. If we tried 3 times 3 times 3, that's 27. So it's jumping right over this number. There's no cubed root, a perfect cubed root for 37. So we're just going to leave it exactly how it is. Again, you are welcome to type that into your calculator to be able to figure that out and see exactly what it is as a decimal if you're curious. And the other two are going to be exactly the same scenarios. So instead of walking through, I'll just show you. So this one, it's a cubed, so it's going to be cubed root of 11. And this one is squared, so again, be careful. When it's squared, we have to include the plus or minus sign. And there you go. So again, not much difference from just learning basic cubed roots and square roots, but now we're just trying to actually solve for them.